Alright everybody, welcome back to another video. In the last lesson we ended things off where we were able to successfully run around, collect spores and grow in size, and we were also able to eat other players and reset their size as well. So in this video we're going to set up a high score system where players can browse the high scores and look at the players who have had the best sizes of all time, and they can even search for the players in the database. So that will add a little bit more competitive fun to our game to make it feel a bit more like an MMO. And to pull this off, we're going to need a few things, which we're going to tackle one by one. So before we get started coding things on the server, let's go ahead and create a new custom class that we're going to use to display high scores, because we can reuse this display both in-game and in a separate scene. So in-game, it's going to display a real-time update of all the sizes of players who are currently on the map. And then we're also going to have a separate scene outside the game that we can access via the main menu. And we're going to be able to browse high scores, top high scores of all time. And we'll also be using our same custom class to drive that logic. So you might recall back from lesson number 3, we created a new custom log class, the process for which is going to be very similar. Our custom high scores class itself won't be responsible for fetching any information from the server, but we're just going to be able to use its functionality from other scripts to display the high scores and update them as well. So we're going to revisit our classes folder. This is where we had our log custom class, but we're going to create a new one. So create a new folder called high scores. And inside our high scores folder, we're going to create a new scene called highscores.tscn. And we're going to make this a scroll container. So now that we're in our new high scores scene, let's set the scroll container so it takes up the entire viewport. So we can click this anchor preset full rect. And we're also going to come into this container sizing menu here and just make sure that the shrink begin option is selected for the vertical alignment, as well as the expand option for the vertical alignment. So this will just set ourselves up so that the high scores node can be resized properly wherever we put it. So let's go and create a bunch of new child nodes. We're going to have a VBox container and a HBox container. And then we're going to have 2 labels inside the HBox container. So the first label we're going to call name, and the second label is going to be called score. So everything's all clumped together at the moment, so let's fix that. For the VBox container, we just want to allow it to expand in both directions. The HBox container already looks good. We just want to make sure that it's definitely shrink begin for the vertical alignment so that everything stays towards the top. And we just want to fill and expand the name label horizontally. And we'll also just give it a custom minimum width by coming into layout and custom minimum size. For the X, we'll just set it to 150 pixels. And for the score label, we're just going to set shrink end for the horizontal alignment. So this will just make sure that it doesn't take up more space than it needs to. So we can put some test data in here to make sure it looks good. So for the name, I'll just type John, and then for the score, 1, 2, 3, something like that. So you can see the name label is pushing the scores label all the way to the right, which is what we want. And everything seems to be aligned properly. So if I was to duplicate this HBox container, we can see how our high scores node is going to look. So I'm just going to save this scene now. And I'm just going to attach a new script to this scene. Highscores.gd is fine. I'm going to give it a class name of highscores. And then I'm going to set up the underlying data structure, which is just going to be an array of integers. So this will just represent all of the scores that we're holding on to. Let me get a reference to our VBox container, which I'm just going to call _VBox. And I'm also going to grab a reference just to this first entry. This is going to serve as like a template. So we can copy this entry whenever we want to add new scores to the high scores node. So I'll just call this entry template. So we're obviously going to need a way to add a new high score. So let's add a function called add high score, and it will take a name string and a score integer. First thing, we're obviously going to append to our scores array. And because we want to keep everything in order as we add more entries to the high scores, we're going to go ahead and sort our scores array now. So scores.sort. And now we just need to figure out where are we going to put the new entry. We can calculate the position of our new entry, the index, by saying var pos is the length of our scores array minus the index of the score that we want to insert. So scores.find score. So this will give us the position that we need to insert it into to make sure that everything is sorted. But we just need to remember to subtract 1 from that index because we need to account for the template entry, which is actually going to be hidden. But we can use this to easily copy and paste, basically. Like we can programmatically copy this node and then paste it when we add a new high score. But this will be hidden. But we just need to remember to subtract 1 from the calculated index because of that. But now we just need to create our new entry. So this is going to be entry template dot duplicate. Then we can just get the name label that is inside the entry template. So that will be grabbing this. And Godot's not really going to know what this is because all it knows is that entry is a HBox container. It's not going to know that there's 2 labels inside. So we just need to explicitly tell it the type. So these are 2 labels. And then we just go vbox.add child entry, vbox.move child entry to the calculated position, and then we're going to update the text. So the name label's text is going to be name, and the score label's text is going to be the score, but we need to convert it to a string. There we go. And then we're simply going to say entry.show because the template was hidden, and when we copy it, it's also going to be hidden, so we just need to make sure we show. So we won't actually be calling this function outside of the script. Instead, what we'll be doing is defining a new function called set high score, which will be publicly available, and it's going to have the same arguments. But what it's going to do in addition to adding the high score is just remove the high score if it already existed. So this is just our kind of way of keeping the list in order. So we're going to define a new function called remove high score in a minute, but here we're going to add the high score. So all we need to do is create a remove high score function. And all we're going to do is look for the entry that has this name. So for I in range length of our scores array, we're going to get the entry, get the name label. So entry is just the HBox container. So the name is the first child of the HBox container. So child index 0. And then if name label dot text equals name, so we found what we're looking for, then we can just say scores dot remove at the length of our scores array minus I, and then -1 to account for the entry template, which we want to preserve. We don't want to accidentally remove the entry template. And then we can say entry.free. This will just tell Godot to get rid of that child from the scene tree, and then we can return because we've found what we're looking for. There's no need to keep going through this loop. So let's test out to see if our custom high scores node is working. We'll just go to the connected scene because this will be an easy place to drive some of our code. So we'll come to the states, connected.tscn, open the 2D scene view, and I'm just going to click and drag my new high scores scene just underneath the log here. So now we have a new high scores node. And let me just set the custom minimum height. So with the high scores node selected, I'll come into layout, custom minimum Y, I'll just set to maybe 200 pixels. And then I'm just going to hack in some testing code in the onReady function of the connected scene. So just after we connect all of these signals, let's just say var high scores is UI slash, well, let me just do it like this. I'll just drag the high scores node in, and I'll just get rid of this onReady. And then we can say high scores dot set high score, and let's say Tristan, and let's say I have a score of 10,000. And then if someone else comes along and they have a better score than I do, they should be displayed on top. So high scores dot set high score John says maybe has a score of 10,001. And let's also just add someone else who has the worst high score. Let's say Susie, and let's say Susie has a high score of just 1. So she should be at the bottom of the list, Tristan should be in the middle, and then John should be at the top. Alright, so let's run the game. Maybe the connected scene wasn't the best place because I need to actually make sure the server's running, so I'll just go ahead and press F5 in VS Code, and let's try that again. All right, so just as we expected, we've got the 3 characters here, and they each have a score in order from top to bottom, just as we expected. So it looks like our high scores class is working. So I'll just delete this test here. I'll just delete all of that. And I'll just remove the high scores node from our scene. All right, and let me see. It might just be best while we're working to have the template enabled, just so that we can see what we're doing and like what the layout's going to look like, and then we can hide it programmatically in the code. So if I show the HBox container entry template, I need to come into the code and just have a ready function simply to hide the entry template. So entry template.hide. Okay, that'll just make it a little easier to work with. So we're now ready to drop our high scores scene into the game, but first maybe we should restructure a little bit because our in-game scene is currently not the most well equipped to handle this. If we open ingame.tscn and look at the 2D view, it's very simple. We just have a line edit and a log, and if we want to put like a high scores widget sort of in the upper right, it's going to be kind of difficult to do that. So let's actually put all of this in a VBox container. So I'm going to add a VBox container to the UI canvas layer, and then I'm going to put the line edit inside the VBox container, as well as the log. And I'll just make the VBox container's anchor preset to full rect. And we should have the same as what we had before. And let's now put our high scores scene in the middle of the line edit and the log. We'll set a custom minimum size. So let's come into layout. Custom minimum X will be 200 pixels and the height will be 150 pixels. And just to force it to be in the right hand side, I'll choose shrink end for the horizontal alignment. So now we just have a little high scores widget. So just by restructuring that, we will have broken our references in the in-game script. So let's come here and modify the onReady vars to just have a VBox container between the UI and the node. So VBox container, just like that. And while we're here, let's just drop in a reference to our new high scores scene. And I'll just call that high scores with the underscore. So now in order to make the high scores update, every time we update an actor's mass, we should update the high scores list. So conveniently, we do have a function called set actor mass right here. So we can really just add on this logic to this existing method. So we'll say high scores dot set high score, and we'll give it the actor dot actor name, and let's just round our mass to an integer. So round I, new mass. So now when we run the game, we should see my score as I start to collect spores. And I'm not actually seeing anything. Let me try to put a breakpoint here and we can see what's going on. It looks like the breakpoint's not triggering, which must mean our set actor mass is never getting called. Okay, so it turns out the set actor mass might not be actually getting fired when we grow just our own player. So what's happening is our own player is receiving syncs from the server, and the server is sending us our player message, and then we're running this update player function. And this is where we're setting the radius. So it looks like we're getting bigger when we eat the spores, but it's actually just we eat the spores, the server upgrades their version of our radius, and then at some point soon, the server sends us an update packet, which we interpret and we update our radius as well. We're kind of skipping the set actor mass functionality here, but that's not a big deal. What we can do is force this function to get called every time our radius updates, and we'll do that in the update actor function. All right, it's called update player here, update actor. I knew I would get those words mixed up at some point, but let me go ahead and rename this. Basically, just an actor is like a general term for a player, but it doesn't necessarily have to be our actor. So in the update actor method, let's just, instead of setting the radius directly, we will set actor mass actor and rad to mass radius. And we'll also do the same thing when we add a new actor, because that will set their initial high score as well. So let's just do that after we add them to the world. Set actor mass actor rad to mass radius. And let's see if that works now. All right, that looks better. So you can see my high score at the top right. Contrast is not so good, but we can fix that in one of the later parts. So yeah, you can see the high score is updating as well. And if I had 2 players in the game, then as John eats, his score is being updated on Tristan's screen. So you can see on the left-hand side, John's score is 6212, and then as I eat something, it increases. So the only problem is if I quit the game as John, his score will stay here as well. Well, I mean, John is also still there. So we have a little bit of work to do, but eventually we want to make it so that when the player is removed from the game, their score should also be removed. So just while we're thinking of it now, let's just go to the remove actor method, or the remove player method, I suppose. Sort of getting the names of these methods a little bit mixed up, but it's not too difficult to understand what I mean. So the high scores dot remove high score actor dot actor name. So we just want to put this here so we can remember later when we do eventually remove players from the game, not only by eating them, but also when they log out and stuff like that. Then we just need to make sure we remove them from the high scores list. All right, so we have like a live high scores to our game, which is looking pretty good. It would actually be really cool if the high scores could be saved to the database, and attached to each player will be their best score of all time, and then that will be browsable by a separate interface that you can access from the menu. So for that, we're going to need to add a new table into the database to store some player information. So let's jump into the server code, and I'll just stop the server for now. We're going to revisit our old schema file, which we haven't touched for maybe quite a few parts now. So we'll come to internal, db, config, schema.sql. So currently we only have one table called users, but we want to have another table called players, because we want to associate with each user a player, and with each player they should have a best score. So we'll say create table if not exists, players. It's going to have an ID, which is just going to be a primary ID like this. User ID is going to be related to this table. We'll have a name for our player, just in case we want to support having a different player name from the username. We can do that this way. And we'll also keep a best score, which will be an integer. And it'll just default to 0. And we're also going to set up a foreign key, which means this player's user ID column is going to reference the user's ID column. So if we rerun the server, it will automatically create this table for us, but it will be an empty table. There'll be no data inside it. So even though we do have a few users inside our users table, we won't have anything in our players table because it's not going to magically know to add a new player for each user. So we have a few options. What we can do is just really delete our database and force a restart. So everything will be fresh. So you can come to server/cmd and just delete this db.sqlite file. If this was like a production server and we were trying to add an update to our game after players have already been playing the game for some time, this is not the way to do it. But for our purposes, this is going to be the simplest way. If you get to a point where you're on a production server and you need to be careful about the existing data, you can look into migrations. So Squilc doesn't support migrations out of the box. Or I think it supports some really basic functionality to make your own migrations. But you can look into some external tools which will handle this a little bit more gracefully than what we're doing. Basically, what you would want to do is tell the server how to fill out the existing data so that it's compatible with the new data. So if we rerun our game, we should see the db.sqlite file reappear. So this means we have a fresh new database, and that's going to be good for what we're going to do. And what we want to do is create a new query to add a new player into the database. So let's come to our queries.sql file, And we're going to make one called create player. It's just going to return one row, which will be the player that it created. So we'll say insert into players with a given user ID and player name, values. These will be the placeholders, returning everything that we just inserted. So you can see that we're only putting 2 things into the players table. That's just because even though the players table has 4 columns, one of them is the ID, which auto increments, and one of them is the best score, which will have a default of 0. So we don't need to supply this. The only things that we do need to supply is the user ID and the name, which is what we're doing right here. So let's go ahead and regenerate our Go code using squilc. So I'll just type sqlc generate -f server/internal server db config and squilc.yml. So we should see that we'll have updated our models.go. So now we have a player struct and our queries.go as well. So now we can actually use this query to create a new player when a new user registers. So let's come into our states and connected.go. And we're just going to find our register message handler. So that's this one here. And at the bottom of this function, we see user registered successfully. So it's here that we want to add the new user to the database. So we'll say, I guess we'll do this before we send the OK response. So we've just created the user. Now let's go ahead and create the player. So we'll say error equals c.queries.create player. We'll give in the context and db.create player params. And then we'll supply the user ID is the user dot. Oh, I guess we'll need to grab the user's ID. So instead of throwing away the return value of this create user method, of this create user call, we're going to actually save that as user. And then we can say user dot ID, or at least we should be able to. Let's see it. So because user has never been defined, we just need to put a little colon here before the equals sign, just to tell Godot that we are trying to infer the type and declare a new variable. And then we can say user ID is user.id. Okay, so that's all good. And then the name is going to be the username. So now we just check for errors. So if error is not nil, c.logger.printf failed to create player for user. And we'll give the user's name there. And then we'll give an error like that. And then we'll just c.client.socket send generic fail message and return. Okay, so now we're actually putting a new player associated with this user ID into our new players table. So if I run the server now and register for a new user, we should be able to inspect the tables and find a new player as well. So I'm going to register with John with a capital J. Registration successful. So let's come back to the VS Code. I'll press Ctrl-Shift-P and I'll do squillight new query. And let's do select star from players. And I'll Ctrl-Shift-P, no, what is it? Ctrl-Shift-Q. I'll select my db.squillight as the database. And you can see here we have a player with the user ID of 1 and a name of John with a capital J. So this is different from the users table. In the users table, I think I need to put some semicolons in that. So yeah, in the users table, the username is always normalized to be lowercase, but in the players table, we want to like allow the players to put capital letters in their name. So that's what we've done here. All right. So now we have a way to keep players in the database. We'll need to update the player's best score whenever they eat something. So we'll need a query to update the player's best score, and we'll also need to call this query whenever the player's mass changes. But we only want to update the player's best score if their new mass is indeed greater than their current best score. So how do we actually keep track of each player's current best score? Well, we'll need to add a new field to the game object. So if we come to objects, gameobjects.go, where we've put the player struct, we're going to add a new field called best score, and this will be an int64. And let's also add a new field called dbid. This will just be a place to store the player's ID as it is in the database. And this will be useful for constructing queries that require the player's ID from one of these things. So if we want to update the player's best score, we'll need to have this. So it's just convenient to have this associated with each player. And we're also going to need a way to obtain a player when they log in. So when someone logs in, all they're going to have is the user and the user ID. So we'll need a new query to be able to grab the database player from the players table if we have a user ID supplied. So let's get that set up as well. So we'll come into db config queries, get player by user ID. It's going to return one row. So we'll just do select star from players where user ID is the one given, and we'll just limit it to one row, even though it should only return one row anyway. So I'll just recompile my queries, and let's come back to the connected.go, and where we log in, we're going to grab the player from the database. So right before we transition to the in-game state, let's grab the player, c.queries.getPlayer by ID, or getPlayer by user ID, c.dbctx, and we'll just pass in the user ID. So we'll just quickly check for an error, and we'll just send the generic fail message if we were unable to get the user's associated player. And I suppose we should do this before we send the OK packet. So we're actually going to move this up here, because we don't want to tell the user that they logged in and then go ahead and send them a fail message. That doesn't really make any sense, even though this should never happen, but you know, just in case. Which means we also need this to appear up here as well. So if all goes well, we'll tell the player they logged in and send them an OK response. And then we'll be setting their state. And instead of just supplying the username, let's actually supply them the player.name, which is for us pretty much the same as the username, except it could contain capital letters. We'll also set the DB ID to be the player's ID, and their best score is going to be their best score from the database. So now we are actually able to get the best score information into our players struct, and we can use that when we're determining whether or not our new mass is better than our best mass of all time. So we're going to need a new query to update the player's best score. So let's call it update player best score. Update players, set best score equal to the new best score. And I guess we'll do it by player ID, where ID equals the given player ID. And actually we're not returning anything, so we'll just use exec. This is kind of like a void function. We're just running this query, but we're not returning anything. So we just need to call this function every time we eat something, basically, but only if the resulting mass is better than our best score. So I'll regenerate the Go code once again. Now we can finally come back to the in-game state. So states in-game.go. We'll find where we are consuming spores or consuming players. So in our handle spore consumed function, after all this, we just want to sync our player's best score. And because it's going to involve database operations, we should do it in the background. So we'll do go to run this in a Go routine, g dot, and we'll make a new function called sync player best score. So this doesn't exist yet, but we will define it in a second. And we'll do the same thing at the end of the handle player consumed method. So we'll just run it in the background, sync the player's best score. So let's define this method, sync player best score. And what we want to do is we'll grab the current score, and that will be rad to mass g.player.radius. So the mass is the score, but note how this is a float 64. We want it to be an integer. So we will just do math.round, and this still gives us a float 64, but then we can cast it to an integer. Now we can just say if current score is greater than g.player.bestscore, then we'll set g.player.bestscore equal to the current score, and then we will update the player's best score. So error equals g.client.db transaction.queries.update player best score. We'll supply the context, and then we'll need to supply the params. db.update player best score params. ID is the g.player.database ID, and the best score is going to be the current score. Or we could even do g.player.bestscore just to make it look nice, because we are already updating that here. And then we'll just check if we got an error. We'll just log it. And printf. So yeah, basically every time our score is being updated, we're just firing and forgetting this method. And we don't really care about the whether or not this method actually gets complete. But the only time we do actually really want to make sure that this happens, and we want to wait around for this to happen, is on the onExit method. So onExit, this is the method that gets called when we leave this state. So when we leave the game, basically, what we want to do is we really just want to make sure we run this outside of the Go routine. So sync player best score. And the reason we want to wait for this is because we don't want the player to lose any progress. So if they just get their best score of all time and then they immediately exit the game, we don't want to just run this in a Go routine and it may or may not complete before, like, you know, the connection gets closed and then everything gets shut down. We just want to make sure we wait for this. All right, so let's test if this is working. I'll just start the server and I'll start collecting a few spores as John. So my current best score should be around 1600, but if I start to collect some spores, we should see that number update. So let's come here and go new query, select star from players. We see John currently has a best score of 5700. Let's add some more. Now it's 9775. So that's pretty good. Let's get it to 10,000 or 11,000. Looks good to me. And let's eat something, so it should be more than 12423, and then we'll quit the game straight away. All right, let's try. Yeah, this is more than 124, so it seems to be working correctly. And if we log in again, and we should see our best score is still 12810. And if we collect maybe just a few spores, let's see. Yeah, our best score is still preserved. So it seems to be working as intended. So we've got the data in the database. All we need now is a way for the client to request a high score board from the server. And then the server should be able to respond with the high score board, which is just going to be a list of high scores of every player in the game. So in terms of requesting a high score, we're going to make a new packet. And it's just going to be called high score board request message. And this might be our simplest one yet. It's just going to have no payloads. So this is just going to be one thing that gets sent from the server, from the client to the server, whenever it wants the server to send it a list of high scores. So we'll make a response called simply high score board, or maybe, yeah, high score board message. And what this will be is this will be a repeated list of just high score messages called high scores. So what's a high score message? Well, let's go ahead and define that here. It's going to just have a name and a score. And we can give it like a rank as well. So the rank can be calculated on the server. So if the server is just returning a slice of high scores, like maybe the results from like rank 100 to 110, and if that's what it's serving to the client's not going to know that it starts from 100, so that's why we're going to associate a rank with each high score message. So I'll recompile my protobufs. Oh, actually, I should register these with the packet. And recompile. All right. So I've just added these three to the packet. So let's make a helper function. And we'll call it new high score board. And it will take a slice of high score messages. We'll return packet high score board with a message of a high score board message, with the high scores array being the one that was supplied. So in terms of sending this new type of packet, it doesn't really make sense to do it in the connected state or the in-game state. Basically, in the connected state, we will be listening for the high score board request packet from the client. And if we receive that, we're going to immediately transition into a new state called browsing high scores. And on the onEnter method of that new state, we're going to send a new high score board to the client. So let's start by creating a new state. So under states folder, let's create a new file called browsing high score, browsing high scores.go. And this needs to implement the state handler interface. So let's put that up on the right hand side just so we can see which methods we need to implement. And of course, this is going to belong to our states package. The underlying struct is going to be called browsing high scores. It's going to hold a client. It's going to have a custom logger, just like all of our other states. We're also going to hold on to a reference to the database queries, and same thing for the context. So the name function is going to be simply browsing high scores. The set client method, we're going to inject our client, set the logging prefix, and I'm actually just going to copy this from the connected.go because it's going to be exactly the same. The onEnter method, oh, obviously instead of C dot, we're going to be using B dot. Okay. The onEnter method, wait, why do I have an error in connected.go? Oh yeah, and I need to call this browsing high score. Okay, maybe copying and pasting was, and this should be pointed to a database queries object. All right, we're in good shape. We need to define the onEnter method, which we'll just leave as empty for now. And same thing for the handle message and onExit. So we'll just fill these out one by one. And the reason why we've got these two things, the queries and the DB-CTX members, is just because we know we're going to be using the database a lot in this state. So we're going to have this just to simplify the syntax a bit. All right, so let's come back to our connected.go. And where we're handling messages, let's make sure we check for a high score board request message. Packets.packet high score board request. And then we can just say c.handle high score board request. And let's go ahead and define that just under our handle register request function. And we're literally just going to pass the client onto the browsing high scores state. And that's all we're going to do. And that will have the effect that the browsing high scores onEnter method is going to get run, which means we're going to send a bunch of high scores. So let's go b.client.socket send packets.new high score board. And we're just going to send a bunch of test data just to make sure that this is working. And we'll just do it like this. So let's say rank is 5, name is Bob Barker, score let's say is 100. I'm just going to sort of do this out of order just to demonstrate the fact that it should be displayed in order on the client, but I think in the real world situation this is still going to be ordered. So I'll just make a bunch of test data. All right, so that should be enough to get us started. Let's come back to the Godot side of things now, and we're going to add a new state on the client. And this is going to be also called browsing high scores. And this is going to be where we start listening for the high score board messages from the server. So we're going to open up our game manager.gd script, and we're going to register a new state. So we will call this browsing high scores, and let's add it to our state scenes dictionary. And we'll just give it the path to our imaginary scene that we haven't made yet. So I need to make sure I type this correctly because I don't have IntelliSense. All right, so now we should be able to switch to the browsing high scores scene from the connected scene. And let's just go ahead and make this scene now. So create a new folder under states, and we'll call it browsing underscore high scores. Create a new scene. We'll just call it browsing high scores.tscn, and we'll give it a node 2D, or really I think we'll just give it a node as the root. That's the same as the root for all of our other scenes. So, and we'll call it browsing high scores, just like that. Okay, so in the connected scene, let's look at our 2D scene view and open up the connected scene.tscn, and let's add a new button just next to our register button, and we'll call this high scores. We'll rename it to high scores button. Now in the connected script, let's hook up the high scores button. So let's drag this over here, underscore high scores button, and we will connect it to a handler. and the handler will be defined down here. We're simply going to set the state to our browsing high scores state. And inside of our browsing high scores, let's create a script to have some logic. So browsing highscores.gd, we're going to import packets, and we're going to create a, well, let's actually come back to the scene view. We don't have anything in the scene yet, so let's add our high scores. So let's look into our classes, high scores, and highscores.tscn. We'll just drag this under the root node. Oh, well, actually, we should make a UI node, a canvas layer, and we're going to call that UI. And then we'll put the high scores underneath the UI node, just like that. And let's just make this look a little bit nicer, but we're going to rework pretty much all of this. Let me just maybe center it, and we'll set custom minimum width and height to maybe 200 and 200. We can make the height a bit, we can make them both a bit more. All right, so it looks a bit sad, but this is what our high scores scene is going to look like for now. We'll come back to the script, and we'll add a onReady var for our high scores node. Then we can make our ready function. So this is kind of like our onEnter method. This is what we do when we transition to the state. So we'll send a, well, first of all, let's connect the WebSocket's packet received signal to a custom handler on WS packet received. And we'll just make that function down here. It'll take a packet and packets.packet. And the other thing we want to do after we connect this signal is send off a new high scoreboard request packet. So because we don't have any payload, we don't actually need to assign the result of this thing to anything. We can just send the packet as it is now. Now, on the receiving end of things, we need to make sure that we're listening to a high scoreboard response. So if packet.has high scoreboard, handle high scoreboard message with the high scoreboard. And then we can define this handler. And what we're going to do is, let's look at what this is. We can see get high scores returns an array, and this array is going to hold high score messages. So we'll come back to browsing highscores.gd, and because it's going to be an array, we'll do for high score message, and it's not going to know the type of this, but we know it's packets.highscoreMessage. In highscoreboardMessage.get high scores, we can unpack the name, the rank, and the score. So name is highscoremessage.get name. Let's actually have the rank and the name together. So rank and name. So we'll have the rank and then a dot, a space, and then the name. So this is just how we're going to display it on this scene. And let's grab the score as well. And now we can do high scores dot set high score, rank, and name with the score. So now when we run the game, just make sure the server's running as well. We should be able to request the high scoreboard and get a response back. So I'll just click this button, which will send the high scoreboard request. And then the server receives that request. The server will transition into the browsing high scores state and then immediately send a response. And now Godot is interpreting this response. So this is definitely what we expected. So all is going well so far. So we're almost there. We just need to actually fetch the top 10 high scores from the database. So we're just going to replace this logic here. So let's make a new query on our database. We'll call it get top scores. It's going to return many rows. And we're going to supply a number, which will be how many top scores we want to get. So for us, we're just going to try to get 10 top scores. And the other number that we're going to supply is going to be the offset. So we can do some sort of basic pagination in this way. So we're going to select name and best score from players, order by best score descending. So this will just make it so that players with higher scores will appear first in this list. We can limit by one of our parameters and offset by the other parameter. So coming back to the browsing high scores state, We'll get rid of this code. We don't need that anymore. We're going to define a constant for the limit, and that's just going to be 10. And we'll just type it as an int 64, since that'll be compatible with our query. And offset is also going to be 0. So by default, we're just going to return the top 10 players starting from the first. So top scores is going to be b.queries.get. Oh, and I've forgotten to recompile my code, so I'll just run that sqlc command. And now I should get my IntelliSense get top scores, b.dbctx, and we need to supply the parameters. So we'll go db.getTopScore params, limit, and offset, and just check to see if we got an error. And we'll send a deny response. We'll make the error message a little bit friendlier. So just failed to get top scores. Please try again later. And we'll return in that case. So let's make a slice of high score messages, and we will limit it to, we'll limit the size appropriately as well. So we're going to make a slice of pointers to high score message packets. And then we'll just loop through our top scores. So we can actually do for rank and score row in our range of top scores. High score message is a packets.highscore message. We really could have written a helper method for this. Not sure why we didn't, but we're here, so let's keep going. So the high scores message expects an unsigned integer for the rank, so we just need to cast these things to unsigned integers. Obviously this is going to be the index in how we're iterating the results, and then this is going to be the offset that we're trying to use. So the overall rank is just the sum of these things plus 1, because the top player is going to have a rank of 1. And the name is going to be the score row dot name, and the score will be the score row dot best score. And then we'll simply append this high score message to the high score messages slice. And at the end, we'll just do b.client.socket send packets.new high score board with the high score messages. And I just need to cast the score as an unsigned integer as well. All right, so let's try rerunning, and let's see if we get some real data this time when we request the high scores. So it looks like we're getting John because he's the only user in our database so far. Let's try making a new person. Register. And I guess I didn't have to play because I would have had a score of 0. So that would have been good to test. So, I mean, let's give ourselves a score of about 5,000. And we'll play as someone else as well. We'll just register Susie. So she should have a score of 0. So we see John has the best score, and then Tristan, and then Susie. All right. So you'll probably notice as well, there's no way to go back to the main menu once you're in the high scores board. So that's something that I'm going to leave to you as homework. See if you can figure out how to add a button to this high scores scene that sends a message to the server that we want to switch back to the connected state, and then we'll switch states on the client as well. But we'll be going over that at the start of the next video as well. So that's it for this one. We've successfully added live high scores to the game, saved the player's best score to the database, and made a way to request, retrieve, and receive that information in a new state. So in the next video, we're going to be making the game a little bit more interesting by making players drop spores and lose mass over time, which will incentivize them to keep collecting spores in order to get bigger. We're also going to provide users a way to search the leaderboard by player name. And yeah, this was a bit of a long one, but the next video should hopefully be a bit shorter. So if you had any questions or feedback, either drop a comment on the YouTube video or join the Discord server, where you can talk to other game devs who are following along this course. And if you liked this video, please leave a like on the video as well. But apart from that, I'll see you in the next video.